Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. In this lesson, we're going to cover a new chapter, Flexible Manufacturing System. Before we proceed, I would like to recall what is Manufacturing System or MS. So there are four components in Manufacturing System. The first one is production machines, which includes tools and fixtures. Then we have material handling, to handle the materials, to transport the materials. The third component is computer system, to coordinate and control the manufacturing system. And the last one is human worker, to operate and to manage the systems. So there are several factors that influence the manufacturing systems. Basically there are three types of classes in manufacturing systems. So the first one is type of operations. So different materials, different size of materials, different weight of materials, geometry and complexities can influence the classification of manufacturing system. The number of workstations, either only one machine is used or more than one machines are used, can influence the classification of manufacturing systems. Then there is a level automation. If there is one worker working at the one station, then we call manning level M equal to 1. One worker per station. If there are two workers working at the single station, the manning level is 2. For example, there are two workers doing the loading and unloading a single large piece of aluminum sheet that going to be processed or stamped in the stamping machine. So there's two workers in one station. So the manning level, or we call as M, equal to 2. Another factor is system flexibility. How the system react or respond, or to cope with certain level of variation in the part or products without interruption in the production. So how whether it can quickly change the operating instruction, or can it quickly change the physical setup. So this is the different level of flexibility. So those factors influence the classification of manufacturing systems. So there are three classes of manufacturing systems. The first one we call as single station cell. So in single station cell we have one workstation, either manually operated, like a lathe machine or turning machine, milling machine or drilling machine, or we can have a semi-automated system like a CNC, but then the part or product is loaded and unloaded by a worker. So this is semi-automated machine. Or we can also have a single station but fully automated. So this is one single CNC machine and assisted with automated handling system. So this is the first classification of manufacturing system. Then second class of manufacturing system is multi-station with fixed routing. So there are more than one machine. That's what we call as multi-station. It can be manual. It can be operated manually, or it can be operated in semi-automated, or it can be fully automated. And the fixed routing is referring to part or products that undergo similar sequence of operations. Okay, if there are multi stations, okay, but the sequence of operation is variable, okay, we call it as multi-station with variable routing. Okay, so the part or products in this multi-station are processed in a variety of different session sequence. So this is what is implemented in cellular manufacturing and flexible manufacturing system, or FMS. So cellular manufacturing is following a manufacturing philosophy, okay, which we call as group technology, where parts are grouped into similar processes. Okay, for example, in this figure, we have different parts or products, but they have or undergo similar manufacturing processes. Okay, so in the basic version, the parts will be machined or processed using turning machine, and according to the style, okay, or design, the next version will be maybe drilling or milling. Okay, so these parts is considered as a part family. As a comparison, in process layout, similar machines are grouped together. So we have hydraulic presses, okay, grouped together, milling machines grouped together, lathe machine grouped together, welders or welding station are grouped together. So if there is a part family, okay, and this part family has to be processed or machined, so it has to follow a sequence of operation. For example, maybe it need to go to the lathe machine first, then maybe it need to go to the milling machine, and lastly it will process in the, or will be weld in the welding station. Okay, so in this operation for the part family, it involves a higher transportation time, okay, to move the parts from group to groups, okay, from lathe to milling group, from milling to the welding station. So the setup time also will be higher, okay, when a new part family or different family need to be processed. So it will involve a change of tools or settings such as speed or feed rate. In contrast, in the cellular manufacturing, the machines are grouped, okay, or put in cells, which each cell will produce a part family. Okay, for example, this cell may be produce a part, okay, part A, and this cell will produce another part, okay, part B. This is another cell will produce part C, and so on. And in this cell, there are some workstation or machine. For example, maybe the first one is hydraulic presses, then milling machine, then turning machine, and welding station. Okay, so all of these machines are configured to produce a type of part family. Okay, we go back to the different classes or classification of manufacturing systems. Okay, the cellular manufacturing can be set up or implemented in manual or automatic approach. But if the machine are set up in automated approach, okay, then we can or there is a possibility that the setup or the system is flexible manufacturing systems. Okay, so how are we going to know that the system, okay, or a class of manufacturing system is considered as FMS or flexible manufacturing system or not? Then we have to determine, okay, whether the system can pass 4 flexibility tests. So there are 4 flexibility tests to determine whether system is FMS or not. Okay, the first one is part variety test. Okay, can the system process different part or product styles in the mixed model mode? Okay, so in the normal batch mode, part or products are produced in a specific quantity in a specific time frame. Okay, so in a non-batch mode, there is no specific quantity, okay, to produce the parts. So if the system can accommodate different part or product style, okay, in the non-batch mode, then we can say that it passed for the part variety test. The second test is schedule change test. Can the system readily accept changes in production schedule? So if there is changes, okay, for example, there is a new part introduced to the productions, so how we can readily accept the production schedule? If it can easily or readily accept the changes, so we can say that the system passed this test. The third one is error recovery test. Can the system recover gracefully from equipment malfunction or breakdown? Okay, so if there is one machine breakdowns, can the other machines back up or recover the production from the breakdown machine, so the entire production will not be interrupted. Okay, the last test is new part test. Can new part design introduced into the existing part mix with ease? Okay, so can we quickly change the operation instruction? Okay, and can we quickly change the setup, okay, to accommodate for the new part? So these are the 4 tests, and if the answers are yes for all the tests, we can say that the system is a flexible manufacturing system. So FMS is a class of manufacturing system that can be quickly configured to produce variety of products. So you can read the rest of the slides. Please read thoroughly and understand the concept, okay, in the FMS. So I hope that the explanation given in this video can help you to understand better. Thank you very much.